The video starts by showing our first implementation in one of our test areas in Mallet Place 6th floor. It shows our prototype setup, which includes a grid eye connected to our Raspberry Pi placed in the ceiling of the room. However, in our prototype, this is powered to the plug with a wire, as we didn't have access to the main power in the ceiling. We are displaying the results collected by the Raspberry Pi on the screen of the laptop to observe our results. We observe that there are 2 students under the area covered by the grid eye. The computer shows the data directly in the IBM cloud, meaning the sensor data is being transmitted over wireless Wi-Fi to the cloud. We are seeing live updates reflected on the cloud, with a small latency since we collect data every minute. We will soon be seeing that as the cameraman approached, the recognized number of people goes from 2 people to 3 people. We will have to wait a little bit under a minute to see these changes being reflected on the cloud. There we go. We can see that the number of people has risen from 2 to 3 live. Soon, another person will leave the area covered by the grid eye, and the number of people will drop from 3 to 2. We can also see that the processing of the raw data has happened in the board, since the cloud only received the number of people, and not the raw 8x8 matrix of the heat values. We then go on and demonstrate the raw data that the grid eye is actually sensing, to show how accurately it is picking up shapes and different levels of heat. The hand and shape of the peace sign is completely identified with the highest heat intensity levels compared to other background heat levels. In the second movement, we can see that the hand will be approaching and leaving the sensing area, being reflected in our Panasonic testing software very quickly. We can see it is accurate and responsive. Moreover, we will also demonstrate the Pi camera in action. We can see that for an image taken with 2 people in it, the algorithm has identified 2 faces